Okay, so for this unit, we want to look at some applied problems with trig and just kind of reinforce that finding the missing triangles that we've struggled with a little bit. So looking at this one, we've discussed two strategies for finding right triangles in these. One of them was looking at horizontal and vertical dimensions that intersect to find a right angle. That's not what we're going to do here. What is our second strategy? Do you remember? A radius of a circle to a tangent. Here we have a couple circles and we have tangents. This line across here is tangent right there. So we draw a radius to that point. I'm going to do the same on this circle, radius to that point. I know that this is 0.875 here, half of my diameter. This is going to be 0.625, half of that diameter. From that, I'm hoping I can find some angles. Connecting the centers of my two circles, I know that is 1.200 because it's labeled down here. A second strategy we discussed was draw parallel lines. The reason we draw in parallel lines is parallel lines will either form a parallelogram, or if we have right angles like we do here and here, it'll form rectangles. If I draw a line parallel to this here, right here, it creates a rectangle here. More importantly, it creates a right angle here and here, which gives us a right triangle. So the parallel lines here, not only they give us the right triangle, but then they also give us this rectangle where we have known dimensions. The nice thing about rectangles is we know that if we know the dimension of one side, we know the dimension of its opposite side. Since I know that this here is 0.625, I know that this here is 0.625, which means this small piece here has to be 0.875 minus 0.625, otherwise known as 0.250. What are we going to do from that? Yeah. At this point, we have a right triangle. I'm going to draw it like this. But we know this is 1.200. That is the hypotenuse. This is 0.250, which is the one of the legs. We can find this length here, which will be our length x, by simply doing a squared plus b squared equals c squared. So here's x. X squared plus 0.250 squared equals 1.200 squared. Now, we know how to solve this. We can jump to x is the square root of 1.200 squared minus 0.250 squared. Now, I'm going to pause here. How many of you, did I lose any of you going from this to this? Jason? Okay. So we're just going to punch in. Second square root 1.2, I'm going to leave off my zeros, squared, minus 0.25 squared. 1.174. Oops. So x is 1.174 inches. So that's one of the dimensions we're asked to find. Now that we have that dimension, I want to find the angles of this. Probably the more important angle is this one up here, which I'm going to call angle A, because that's the one that defines the circles more. I'm not going to use the 1.174 for two reasons. One, at the very least, we know it's rounded off because our calculator kept going when we did that. The second reason is we calculated that dimension. We're not totally sure it's correct. We know that these two dimensions were pretty much given to us those we're pretty confident in. So to find A using those two dimensions, the 1.2 is, of course, which side of our triangle? Hypotenuse. 0.25 is adjacent. It's next to the A. If we're using angle A, that's adjacent. Adjacent and hypotenuse make what trig function? Cosine. Is adjacent over hypotenuse. So now I'm going to plug in the numbers. Do I know the angle? No, that's what I'm looking for. It's angle A. The adjacent side, well, I better know that. If I'm missing the angle, I have to have both sides. So 0.25 and the hypotenuse 1.20. When I am looking for the angle, what do? Inverse whatever the trig functions. This is cosine. It's inverse cosine. So second cosine, 0.25 divided by 1.2, close my parentheses, 77.98 degrees. So that's that angle. So once I know that this angle here is 77.98 degrees, I want you guys, little review, take a couple minutes, try to find perimeter and area of this whole thing. So the perimeter, I want you to do the perimeter first. That's the distance around this whole thing. So for right now, try to find the perimeter quick. I'll give you a couple minutes.
Triangle.
Yep. When I go to do perimeter of this, I'm going to break it into 4 parts. Two parts we already know. This straight line here and this straight line here. Both of those should be the same. We figured them out to be how much? 1.174. So we got that one and that one. So I'm going to put those to my list here. So we got 2 of them. Next, I have this arc of this circle. I'm going to draw this in to make it easier for us. I know that this radius is 0.625. Do I know this angle? So 77.98 times 2. Because remember, if I draw this out, since this and this diameter, or this radius, both are right angles here, they had to be parallel. So this angle here and this angle here have to be the same. So 77.98 times 2 is, what, 155.96? Somebody double check me there. Yeah? Okay. How do we use that angle? What's it do? What's it help us with? Very good. It's that out of 360. What we need to know first is what the circumference of this whole circle would be. Circumference is pi times diameter. So pi times 1.250. And then we would multiply by 155.96 over 360 to reduce that to that arc length. Does that make sense? So I'm just going to use 3.14 times 1.25 times 155.96 over 360. 1.700. So there's that one. How about this one over here? Do I know this angle? Kind of. Yeah, it's 360 minus the 155, so it's going to be 204.04 degrees. Because this over here is the 155.96. So that one, the circumference, of course, is going to be pi times 1.625. Right? No, that's 1.75. 1.75. Thank you. 1.75 is that diameter. Times 204.04 over 360. So 3.14 times 1.75 times 204.04 divided by 360. 3.114. Where do they overlap? We're talking perimeter now. Oh. We're not talking area. Okay. When we go area, there's going to be overlap, but if we break it up right, we don't have to worry about overlap. Okay. So we're going to add this up. 12, 16, 11, 7.162 inches is the distance around that. Make sense? Area is the next step. And I do want you guys to look at this for a second, see what you can figure out for area as well. And then we'll go over that in a minute. So dividing this one up is going to be divided very similarly. We have our right angles here. So let's look at those shapes. Had I drawn this well, which you guys know my artistic talent, these two are identical. We have two trapezoids. They're the same length. This is 1.174. That would be the height of the trapezoid. If I'm setting it like this, that's the height of the trapezoid. This is the radius of that top circle. So that's the 0.625. And this is 0.875 down here. How do we find its area? Perfect. Remember, we turn things into rectangles. That trapezoid can be turned into a rectangle. It still has a height of 1.174, but its length is the average of the two bases. So 0.625 plus 0.875 over 2 to average them together. If you're doing that on your calculator, make sure you add them, hit equals first before you divide by 2, and then times the 1.174. Now this next part I'm going to do right in my calculator. Because there's two of those, I get 0.8805 and 0.881 is my area. Since there's two of those, what do? Multiply by 2? Yeah, there you go. Question was almost too easy. Thought it was a trick. Huh? 1.761. That is square inches. Remember, this is area. It's inches squared. Yeah, at this point in the math class, when you get an easy question, you start to
get scared.
Get a little worried.
I wonder if I need to write NA.
Yeah. If I didn't know better, I'd swear you guys didn't trust me anymore.
Yeah.
Let's look at this one again. This angle here, 155.96 degrees. So that area, just like with the arc length, where I found the circumference of the whole circle and times that angle over 360, area is the same way. We find the area of the whole circle. So that'll be pi times radius of 0.625 squared times the angle 155.96 over 360. So 3.14 times 0.625 squared times 155.96 divided by 360. 0.531 it looks like we're getting. Square inches. Everybody with me so far? On the other side then, same issue, only this is 204.04 degrees. This is 0.875 is that radius. So that'll be pi 3.14 times 0.875 squared. That's the area of that whole large circle times 204.04 over 360. $1.363 x squared. And at this point, that's it. So we can add them up. .655 square inches. Works for me.
You could also calculate the area of the two rectangles on either side,
We
right?
find the triangles.
And then in the middle you have
Well, you could have a
the
kite.
two triangles.
Yeah, you could have two triangles or a kite, depending on the.
Okay, yeah.
Yep.
You could do something, so.
Yep. Any questions on that one?
Go back up just for a minute.
Sure.
Right.
Actually, we're going to do this as a half circle, just to start out gently with you guys. So that is a half circle. This is a tangent. We're going to say this half circle has a radius of 40 millimeters. This here is a 3-to-1 slope or a 1-in-3 slope. This is 12 millimeters. Our first exercise, we want to find that distance. How do we find that distance? You ask me? Since you guys are former students, I'd only charge $30 an hour in my consulting fees. I would charge you half price. 12 times 3? That'd be nice if it worked out that easily, but no. Well, we know we run a radius here. If that's a tangent, that's a right angle. Does that do anything for us? It does give us, no, it doesn't really give us a trapezoid because the right angle over here is right there. So that's not necessarily a trapezoid. Actually, it's not a trapezoid because you don't have any opposite sides that are parallel. Not a parallelogram. Parallelogram has both pairs of opposite sides parallel. It's just a simple quadrilateral. Yes, sir. Okay, you are going to use the 3-to-1. If we cut this across here, and I don't know how far we're going to go, I'm just going to stop there. I can find this angle. that angle comes off of this 3 to 1 slope. This is the 1, this is the 3, correct? That angle is this angle here. Anytime we have a slope factor or a taper factor like that, we can find that angle. According to that angle, if I call that angle A, this is which side? Opposite. This is adjacent. What trig function uses opposite and adjacent? Tangent. So I'm writing out my definition of tangent. Tangent of an angle is opposite over adjacent. Do I know the angle? No, that's the angle A that I'm looking for. Opposite side is 1, adjacent side is 3. Now here, remember, it's the ratio between the sides that matters. So even though I don't know the actual lengths here, I know that the ratio is 1 to 3. So that's all I need to know to figure out the trig function here. So to find that missing angle, it's the inverse tangent of 1 divided by 3. So second tangent, 1 divided by 3 equals my parentheses, and I get 18.43 degrees. How's that help me? Tells me an angle, okay. I'll help you out here. Does that do anything for me? Yeah. I drew it in. It must help us, huh? Maybe. Oh, you guys tell me.
Well, now we gotta make the angle on the triangle. Figure out how, triangle.
Blue triangle. I mean this one here. That one. Well, I know that angle is probably what? 18.43. How is that 18.43? Yeah, because since this is a right angle here, this is a right angle. I know if this is 18.43 here, this one up here is 71.57 because this is 90, so these two have to add up to 90 to get the full 180. Well, since this is a right angle here, this one has to be 18.43 to add those two up to 90. Remember that 90s and 180s are huge when we're dealing with triangles. So once that's 18.43, I do kind of know this length here to be what? 40. That's 40. This is 18.43 degrees. I can find this dimension right there and this dimension right here. You want to tell me how? Let's find this one. We'll call that side D. We'll call this one side E. How do I find D? Cosine of an angle is adjacent over hypotenuse. Do I know the angle? Yeah, 18.43 degrees. Do I know the adjacent side? That's what I'm looking for. Do I know the hypotenuse? Well, I better. I can only have one unknown, right? Put this over 1. So this is just cosine of 18.43 times 40 divided by 1. So cosine 18.43, close it up, times 40, and I don't have to divide it by 1. 37.95 millimeters. E then, we can either do a squared plus b squared equals c squared, or, while I'm at it, since we got the trig functions out, I'm going to do sine of an angle. Since E is the opposite side, and it's still 18.43 degrees. Bless you. E is my opposite side over 40 is my hypotenuse. Put this over 1, so it'll be sine of 18.43 times 40 divided by 1. Again, don't have to divide by 1. 12.65 I get. So no, this is 12.65. Now technically right now that 12.65 doesn't do anything for us, but I found it because I know I'm going to need it in a few minutes. What's more important is that this dimension from here to here is 37.95. How does that help us? Well, because I know the dimension from here to here is how much? 12. That's where those rectangles come in. We know that the dimension on one end has to be the same as the dimension on the other. If that's 12 and from here to here is 37.95, that means on this triangle here, this dimension is 37.95 minus 12, which is 25.95. Objects on paper may not be drawn to scale, by the way. Considering 12 is twice as long as 25 in my paper, maybe a little bit off. I know that's 18.43 degrees. I am trying to find this side. I will call that side B for now. This is which side of the triangle, according to that angle? Opposite. And what I'm finding down here is the adjacent, which is a tangent. Tangent of an angle is opposite over adjacent. Do I know the angle? Yes, I do. Do I know the opposite side? Yes, I do. Do I know the adjacent side? Better not, because otherwise I'd have nothing to look for. Put this over 1. Now it's 1 times 25.95 divided by the tangent of 18.43, giving me 77.87 millimeters. How does that help me? This is 77.87. If this is 77.87 up here, the bottom of the rectangle has to be the same. Now x is just a radius of 40 plus the 12.65 plus the 77.87. Which gives us a total of 130.52. You got it. And from there, I'm going to let you guys, as part of your homework, not on this particular problem, but the problem you're going to get on your homework, find the area. So that's going to end our presentation for today. I'm going to pass out your worksheet for your homework.
All right.